So our next talk is a remote speaker who'll be joining us for Select Star from the Cloud. Before we kick things off, I do want to thank our sponsors, especially Flatiron. Flatiron Health is a healthcare technology and services company focused on accelerating cancer research and improving patient care. Our platform enables cancer researchers and care providers to learn from the experience of every patient. For more, follow us at Flatiron Health. Please welcome Saurabh.
Okay, hi everyone. My name is Saurabh Wadhwa. I am a senior sales engineer at Uptycs, and I would be talking about how the organizations can simplify cloud security analytics using Cloudquery. And during the talk, I would be covering a few different topics like how Cloudquery came into being, what are the benefits, like how you can ask questions from your cloud infrastructure in a simplified way, and how you can implement it in your organization, which is also really simple. So as you can see from the title, Select Star for the cloud. So it's basically all about SQL, right? And as I read somewhere, if you have control over SQL, you have control over information. It will be more relevant as we go ahead with the presentation. Okay. So this would be the agenda for the talk. Introduction, cloud security and visibility challenges, structured telemetry, what it is and why do we need it. Introduction to osquery, I'll briefly touch upon what osquery is. Introduction to Cloudquery, that's the main topic of discussion. A small demo and a wrap up. So before we start with the presentation, let's take a look at some cloud security predictions by Gartner. So through 2025, 90% of the organizations that fail to control public cloud use will inappropriately share sensitive data. Through 2024, the majority of enterprises will continue to struggle with appropriately measuring cloud security risks. And through 2025, 99% of cloud security failures will be the customer's fault. It's sad, but it's true. So here are some cloud security and observability challenges. So as you can see from the bar graph, the biggest challenge the organizations facing today is the visibility into and control over the sensitive data. Then applying consistent security control policies across your cloud and on-premises, maintaining compliance. So making sure that your cloud resources are not drifting from the baseline. And also rogue use of cloud applications that even IT doesn't know about. So these are some of the challenges that the organizations who are in the cloud or who are in the process of migrating to the cloud are facing right now. And there is this huge expansion of cloud native applications and gaining visibility across multiple accounts and also multiple environments, I would say, if someone is using AWS and GCP and Azure, the visibility across all these cloud providers is really, really difficult. So let's touch on the modern attack surface. Modern attack surface is, I would say, an entry point for the malicious actor, right? The attack surface. Traditionally, it was consisting of the productivity endpoints or production endpoints, the server is hosted in your data centers or even the user's laptops, then claim the cloud. Now you have all those applications running in cloud, whether it's IaaS or SaaS services. Then you have containers like Docker or the whole new world of Kubernetes, and even identity providers like Okta, Auth0, Ping Identity, and so on. And SaaS applications like GitHub, where the code lives, Salesforce, Dropbox, G Suite, and Office 365, where the work gets done, right? So the modern attack surface is increasing day by day, and hence it's increasing the risk for an organization as well. So structured security analytics. Right? On the left, you see all these different sources of information. And how do they come together? Because these these different sources are hold tons of information. They are outputting it in different formats. How to bring them together in a uniform way where the users can analyze the data and make sense out of it. So that's where our tool suite comes into the picture. So we have osquery, which gives us data for the hosts, VMs, containers. We have kubequery, which is container orchestration visibility. We have Cloudquery, which is a topic for today's talk. Then we have SaaS query, which is coming in the future, where we will be getting the data from the different SaaS applications, and identity query for the different identity softwares like Okta or Zero Ping Identity and so on. So structured analytics, why? Right? As you can see from the meme on the screen, that when you control the SQL, you control the information. Right? So you have the different sources pumping out information. You want to correlate the data. You want to make sense out of it. How do you do that? That's through like different tool suites that I touched upon previously. And in structured security analytics, basically what we are doing is we are bringing in the data in a structured tabular format, and you can write SQL queries, simple SQL queries to get more information. For example, select star from IAM roles. In case of AWS, if you want to get more information about, the roles, the policies, the users, what roles they have, and so on. So getting the data from all these disparate sources in a uniform way and using the existing familiarity with SQL to type queries, get the data, is what structured security analytics means, right? And how is it useful is that it lessens the impact of familiarity with the attack surface data sources. So you have GCP, AWS, all the identity tools and SaaS tools. They're pushing out data in different formats, and not all the people working with the data will have familiarity with the different formats. So Cloudquery is a great way to get the data together in a structured format, in a tabular format, and run queries against those. Now, introduction to osquery. So osquery is a framework which was open sourced by Facebook in 2014. Eventually, it was brought on by the Linux Foundation in 2019. It supports all the three major operating systems: Mac OS, Linux, Windows, and even FreeBSD. So what it does is it structures the endpoint telemetry as SQL tables. Right? Imagine the processes running on a machine, the files that have been opened, have been modified. It's as simple as querying an SQL database like select star from processes, right, in real time, or going historically. So osquery has a really low resource utilization footprint. So what it does is it has a watchdog settings. If a query is taking a lot of time, then it will automatically go in and kill that query. Some of the use cases of osquery are endpoint detection, investigation and threat hunting, and audit and compliance. So osquery has this on this database called RocksDB, and it consists of two different processes. Right? One is osquery D and one is osquery I. So osquery D is the daemon running in the background, which is running scheduled queries, getting the data. And osquery I is interactive. So it's like any command line interface. So you just log in, you can type queries and get the data in real time. And when you get the data from osquery, you can actually send it to various destinations like third-party tools. If you want, you can push out the data in JSON format on disk, and even send it to Kinesis, Kafka upstream, or send out the data to any SIM, for example, Splunk. Right? Now, coming to introduction to Cloudquery. So it's an open source extension to osquery, which was released in 2021. it extends the SQL-based analytics to cloud infrastructure. So just as we saw with osquery, Cloudquery is an extension. So you can just take the SQL queries and start um, writing queries against your cloud data. Let's start from EC2 instances if you want to see what instances are running, like what regions they are running in, and so on. And Cloudquery supports all the three major cloud providers, AWS, GCP, Azure. You can run scheduled queries and you can also run real-time queries, but it's running scheduled queries make no sense because you don't have to query the API again and again. Some of the use cases of Cloudquery are resource visualization. So it's really important to gain visibility in your cloud infrastructure, right? You might be having a lot of cloud accounts. They might be running a lot of services like EC2, RDS, creating a lot of S3 buckets, and you don't have any visualization, like how many instances are there, EC2 instances, for example, and if they're running in the correct region. If any user went in and launched an instance in a region which was not allowed. For example, I am a US user and I went in and spun up an EC2 instance in APAC region, right? So looking across your different services, then monitoring configuration and drift. So for example, if you have baseline compliance, it might be specific to your organization, or even if you are looking across different benchmarks like CIS, SOC 2, you can see how compliant are your services and how many are drifting away. Then investigation. So if something goes wrong in your within your cloud infrastructure, so you can go back and investigate what exactly happened. Now I'll show you a use case, right, and which will show us the power of structured telemetry, right? And this would combine osquery and Cloudquery both. So take, for example, I am a really disgruntled employee, right, or any attacker from outside, and they may have access to AWS credentials. Like what they do is they log into the AWS account, they use a trusted AMI to launch an EC2 instance, and it's an Ubuntu machine, right? And which in turn connects to an S3 bucket, which is holding sensitive data. Then so the EC2 instance has access to the sensitive data from the S3 bucket. What the malicious user does is he invokes a script which runs a curl command. So curl command first does a DNS lookup, right? And that domain actually has a malicious reputation. Once he gets the IP back, the curl command establishes a socket connection and opens up an HTTPS communication, gets the data from that S3 bucket, exfiltrates it, closes a connection, and that's it. All done. The data has been exfiltrated by just one, I would say, exposure of credentials. In this case, there are two pieces. One is Cloudquery. So the user logging into the AWS account. So there are different tables, which can give you information like, IAM, what user logged in, what were the policies, what was the role. EC2 then EC2 instances, S3 bucket, if the bucket was public or not, if the data was encrypted at rest or not, so you can get all that information, and even CloudTrail logs, right? And the endpoint, the virtual machine which was spun up was running osquery. So you can see, for example, the curl process ran. So there would be an entry in a process events table. The DNS lookup events when the curl process actually looked up a domain. So then you will have entries in the DNS lookup events table, and socket events, right, when the communication was established. So you can see the power of Cloudquery and osquery working together to trace the whole attack, right, and giving you that visibility that what exactly happened, within my infrastructure. And here are some of the tables, some pieces of information that you can query. This is for AWS, and the count is approximately 1/3 of the actual number of tables. So we have EC2 images, IAM groups, policies, users, AWS S3 buckets, and so on. Then you have the same, similar tabular telemetry for GCP. So compute disk, compute image, compute instance, IAM role, SQL database, and so on. So let's look at S3 bucket compliance. And if you want to see how compliant are your S3 buckets against these particular checks, right? If ensure that S3 buckets are configured with block public access, right? Different organizations have different needs, and it might be the case that not all the S3 buckets need to be private, right? Because some buckets might be holding something for downloads, right? So it must be public, and then ensuring all S3 buckets employ encryption at rest, right? So getting these answers using Cloudquery is really, really simple. So let's check. Let's take an example, right? In this case, what we are checking is if the data is encrypted at rest. Right? So basically server-side encryption. So we are looking for select when the server-side encryption is not null, then okay, all is good. The data is encrypted, else alarm, right? So it's as simple as running this check across your S3 buckets, right? Just to see if the data is encrypted at rest or not. And even looking for, in case of versioning, right? So imagine the data getting lost. There is a disaster, right? And the versioning was enabled, so you can revert back to the older version of the file in order to check if the versioning was enabled or not. Here is a simple query. So it says select name case when versioning status equal to enable, then okay, all is good, else warning. So it means you can go in and turn on the versioning if you get a warn message. And then checking the password compliance. So again, different organizations have different requirements of how complex a password can be for a particular user. So for example, this is just an example where it says at least one uppercase letter, one lowercase letter, one symbol, one number, all these different checks across the password. So we don't trust, we only verify, right? In this case, how we verify is we check all these conditions. If minimum password length is greater than or equal to 14, you can't use the last 5 passwords, right? And it requires lowercase characters, uppercase characters, and even numbers. And the maximum password age should be less than or equal to 90. So if it meets all these conditions, then yes, a strong password policy is configured. Otherwise, give a warning. So what I've done is, in the interest of time, I ran a few queries, a pre-baked queries. This is because if I ran it in real time, it would have taken some time. That's why I mentioned that it's better to schedule those queries, since it will run at a scheduled interval and get only the delta. Otherwise, in real time, you would be going in and querying the AWS API in our case. So I'll show you how exactly the data looks like. And I ran those queries which I just showed as a part of the presentation. So just give me a moment. So this is how the data looks like, right? So running
could you make it a little bigger?
Sorry?
Could you make it a little bigger? It's very hard to...
Okay. Oh, yeah, sorry. I'll just expand this. Is it visible now?
Just the font a little bit, if it's Command plus or whatever.
How do I?
All right. We can watch it later. Don't worry about it. Sorry.
Okay. So basically, as I mentioned that running Cloudquery in your environment is pretty easy. Here, what I did was I just ran a Docker image directly right? And once I ran the Docker image, it opened up a command line. So it's as like any like with any database command line, I would say like MySQL, and I wrote this query where it says select name, case, and we are checking for the server side encryption. If it's not null, then okay, else alarm. So it gave back the result, and you can always add more fields if you want get more information on what, for example, what the name of the bucket was. Status is okay, it means the data is encrypted at rest. The reason and what region was the bucket residing in, and you can run simple commands. For example, if you want to see a whole list of the AWS tables, it's as simple as writing dot tables. It will give you a whole list, and then you can query against those tables to get more information. And similarly, I ran. I'll just expand this again. Yeah, like the password compliance use case, right? Like how compliant is your password policy? So we specified all the conditions. When if the minimum password length should be greater than 14, and password reuse, you can't reuse the last 5 passwords and so on. But in my case, it was actually not configured, so I will have to go in and change a few things. And this was like bucket versioning enabled or not. Again, it's totally up to you what fields you want to get in the result set. Here I got the name of the bucket, the status, which is obviously won or okay, the reason, and the region code. So you can create your own queries, you can schedule them, and you can run it at a particular frequency to get the data back.
Thank you. I have a couple questions I want to ask from the channel. First, Gaurav asks, can we query any JSON key available in the Cloud API, or are we limited to the columns predefined in Cloudquery?
I think you would be limited to the columns predefined in the Cloudquery, like the column. Yeah, you would be limited to that.
And so I guess then related to that is, if we wanted an additional column or we wanted additional coverage, is there a way for folks to contribute to these tools?
Oh yeah, definitely. It's open source, and we have our developers making improvements to this, so you can definitely do that. Yes.
Cool, thank you. So Ryan asks, when querying the AWS CloudTrail tables, is it actually Athena under the hood? How's it getting access to the data?
It's calling the AWS API.
Okay.
Yeah.
And so if you're pulling data from the API, as a question is like, what's the latency or caching trade-off? Is it always hitting the APIs? Like you mentioned, you don't want to hit the APIs directly, but at the same time, you don't want stale data.
So that's why I mentioned scheduled queries. So what we do is, like if we get run a query, it will get the result set. And when it runs the next time, it will get only the delta. So only the data that has been changed would be brought back. So we won't be overutilizing the API limit.
Okay. And can you explain how you link osquery and Cloudquery sources together? So do you need to query in the same host on the same time frame, or is there something more complex that you're doing in that? Excuse me, in that kind of query?
Yeah, that's correct. So querying both the host and the cloud within the same time frame. But just to point it out that these are independent, so you don't need osquery to be running with Cloudquery. These are independent, but to get the whole picture, you can run osquery and Cloudquery both. And as you pointed out, that to get the whole picture of how the attacks spawn, it would be better if you do the queries within the same time frame.
And last, Ian asks, what SQL dialect is used and where is it stored? Is it possible to have an RDS instance host Cloudquery or OS?
So it runs PrestoDB, and it's like you can run like simple SQL queries for that. So basically, like Ian was asking if he can run his own database at the backend for Cloudquery.
Yeah, I think that's right. Like, so basically make the OS query accessible through like an RDS kind of interface.
What I think is that if he wants both OS query and Cloud query, so Cloud query can be run as a Docker image directly, You can just pull the image from the Docker Hub, and then osquery needs to be installed on the endpoint, and it will depend on what operating system it is. So like these are two different things. So osquery, like if you want, you can explore the open source osquery, but for Cloudquery, you can just download the Docker image, and it comes pre-baked with the the database. You can just run it directly.
Well, thank you. We're for those in the room, we are on break until 2:20, where we'll be doing a talk on managing vendor access in AWS. Thank you very much, Saurabh.
Thank you.
Cheers.